wonderful opportunity it is to showcase, what is the future of steel architecture as such. Here are some of my works which I think you can visualize yet that they are more aesthetical than even the concrete structures that we have today. So, next. So, I just thought to just brief you about increase in usage of steel and particularly in buildings. Let's start with the industrial buildings. Yes, steel we have been using industrial building steel, but they were into absolutely what you call conventional kind, and it has been totally now transformed into something called a pre-engineered building, where we can design based on the architectural design into a software which runs on to prepare a kind of general arrangement drawing on AutoCAD, which we further develop that onto Tekla models. And from Tekla models and Beam, we can get on to the manufacturing part of it. And this is the way things happen, and we can sort of totally sort of control the weather conditions. Durability can be increased, and we will definitely be providing with the underdeck insulation. And of course, now instead of the roofing sheets, we also have sandwich. There are people like ArcelorMittal and so many people are moving in. And I think that is something which is going to be totally what you call paradigm shift into the industrial structures or the other structures. Now, when we are talking about the pre-engineered buildings, steel buildings, as I said, we have a reduced construction time. Because I can even spell out that we take around let's say 1 month to freeze the designs and detail them out into a GAD that is followed by the Tekla model, and then it goes on to the manufacturing. It should not take more than a couple of weeks, and then we move on to the erection. The erection time could be 1.5 to 2 months. So that's the end of the building. And of course, this saves a tremendous amount of cost. There is my presentation called a PEB kya hai bhai? I think it is nationally popular, and where I have compared the conventional versus the PEB, where PEB on a long term will save your cost somewhere around 10 to 15%. There is, of course, it facilitates for the expansion potentials, and you can assure the quality because the design is based on the softwares. We are economizing the design, we are economizing the steel, and the entire process is now defined so that many players have come into the market who can assure you the kind of building that you desire. Now, this building also requires a lower maintenance if it is designed with that kind of a perfection in mind. So we hardly have any maintenance issues. The roof is, of course, energy efficient roof, and we can also have the wall systems. I was talking to you about the puff panels or the sandwich panels, which can be used to reduce the ambient temperature into the manufacturing unit. And there are so many things that we can work out. We can have windows, which could be continuous windows, detailed out in the same kind of steel design, whereas, these windows can throw light and ventilation at the working level in the production hall. And of course, we can provide for architectural versatility, which you have seen in some of the pictures just now, which were shown to you. I'll just take you through some of those also. And yes, it also is an increased accountability day by day because even the softwares are improving. And I think, that we are also becoming an expert on developing from architectural design to an absolutely aesthetically pleasing and functional building. This is the kind of comparison which I was talking to you, a popular article which is available on YouTube, where I'm comparing a pre-engineered building with the conventional buildings. And we have these highlighting features such as structural weight of the primaries, the secondaries, the design consideration, the design, in fact, quick and efficient, as I said, as compared to, old kind of design aids that we had. And then, of course, design B, specialized computer analysis, which you get out of it. And then, of course, the sharp detailed sketches and direction drawings are also made. Now, this is actually completing the whole story. Next. Yes, design E is considered in-house design and drafting time, more complicated design in the olden days. The delivery period could be 6 to 8 weeks as against 20 to 26 weeks. I think I explained to you about the 8 weeks time frame as well. And then similarly, foundations, erection simplicity, erection cost and time. Very clearly, you can see it on the screen in both the ways, and the erection cost and time. The process is very easy, fast, step by step, and with hardly any requirement for equipments. So this is basically on the comparison of pre-engineered building versus the conventional buildings. And of course, there are pages in this article. I'll take you to some of the most interesting projects that we have done, and along with that, the kind of technology that we have used. This is Amber, which is in Supa MIDC. It also is given an award, and it's a huge span, as you can see. As I told you about the continuous windows, we've used the sheets which are Galvalume pre-coated sheets. And then in the next project, which is called Miki Puli, which is Japanese one, we have an underdeck insulation. This entire thing is actually an air-conditioned factory. Right now, I'm not showing you the photo where we have done the ducting, etc. But that is also taken care of, and we have turbo ventilators with it's called combo units, which also are there. This is really very cost effective, as I completed around 50,000 square feet of this factory plus the office building. Beautiful office building, which is also done in steel G+1. Yeah, so this is the this is the kind of article which I was talking about. Yeah, PEB kya hai bhai? This is, according to me, is the, as I call it, song in steel. And they are cheaper. They can be designed the way architects loves to design an industrial building, which doesn't really look like the conventional industrial buildings. So PEB design shall be as per IS code, is what tip I would love to give. Nut bolt should be 10.4 height coated. Professor talked about coating, and that was really a good information. All sheeting screw should have cap of sheeting colors. Now here, the new technology is standing sim. So we don't have to really use the screws on the sheets, because these were the vulnerable leakage points. So now standing sim is actually where you overlap and you sim. So it's absolutely jointless, and there are hardly any chances for the roof to leak. Next. Live load on the mezzanine floor, 350 kgs. This is as far as that particular project was concerned. We have provided safety nets at the skylight panel level, and sprinklers also considered on the roof purlins. Bracings were not allowed on locations of the doors. So we had really, again, a portal frame there. And width of the column, as far as that particular project was, mentioned there. Next. Design data for PB, column out to out, we have to give column center to center along with the length of the building normally. Tile level, very important factor. Column center to center spacing at every grid. Roof slope, location of wind bracing, bracing on the roof and wall. You require the bracings at the corners for what we call as a wind bracing. Roof panel sheet with insulation and its density. It ranges from 24 kgs to 50 kgs, depending upon the panel of, the quantum of insert of the ambient temperature that you want. Wall panel and its distance from column face, side wall girds, and end wall girds. Next. So these are some of the other details like the accessories, daylight panel, frame opening, canopy, paint finish, ventilators, column brackets, fascia. Now, fascia is a very interesting thing which can be handled very beautifully to hide the chip shapes of the roof and the building in general, and the fascia can create an impression of the building. And then, of course, the EOT, of course, can be considered the columns. Next. So this is the process where you actually select. Now, this is very interesting and tricky. First of all, we need to actually compare from vendor to vendor the steel content that they are using it. Then, of course, the erection cost and the project design in terms of plans, elevation sections. Explain the detailed desire by the client and the architect, which is very important. And select the agencies which shall have force acting on, so they will supply the forces to the structural engineer who will actually design the foundation for the stub columns, and agency to submit sets of drawing known as GAD, the general arrangement drawing, which will be checked and verified by the structural designers and the architects. And then, of course, the anchor bolt will be supplied by the PEB vendor, and they will be embedded into the columns to take the primary sections. So then the fabrication will go, and supply of primary section will happen next. So manufacturing, supply of primary section, ancillary sheeting, erection team to move on site immediately, and these are the sequences: installation of roofing sheet and installing corner soffit panels, and then finishing touches, and of course the handing over of the structure. Now some of these pictures will make this concept very clear to you. So we have very thin columns, as this is about 18 meters tall, with gantries at about, I think, 10 to 20 metric tons moving in. And this is also a Japanese company. And we also had loaded mezzanines that you can see on the left, which are overlooking the production. So this is something, an absolute innovation. The entire building is in steel, looks like a multi-storied building. You have a picture, I think, from outside we do have. So yeah, so some of these information about the various stages that we have gone for. Yeah, you can take that slide. Yeah, you can see this building, which is G+3 and a pergola and a terrace on the top. What else architecture you need? Thanks to the steel and the revolution in steel, that now we can design some beautiful buildings such as these, and the industrial structures do not really look like pure industrial structures. Next move. Yeah, so that's the thought process for the multi-storied building. Now, let me tell you that Professor Khanna also mentioned about, concrete outside and steel inside. Now we have a technology called steel outside and the concrete inside. So that is basically steel tubes that we use, and a technology is known as concrete field tubes, which is becoming more and more popular. And all our steel manufacturers are now shifting to also manufacture different sizes of steel with high grade steel strength. And we have constructed buildings which are 25 to 30 storied buildings, particularly one that has come up by an agency in Hyderabad, which is very, very wonderful. And so they have done these buildings which are multi-storied, the way I did this small building a few years ago. Now 25-storied buildings done in only 7 flat months, including deck slab, including CFTs. We also have a new technology called, light gauge form steel, which also is becoming very popular because it's absolute, which is absolutely light gauge, and we can do it within the building itself. So that is the light gauge steel, which is LGS construction, also becoming very, very popular, where, in one of the existing factory unit, we have done a G+1 building without excavation, without plinth beam. We just had chemical fasteners. You can see the detail that I have drawn there. And then we have a framing and all those things all done. About 30,000 square feet done in 30 days. What else, what wonders you want to have? So I think it is going to be more and more encouraging for all the steel industry guys, all the architects, and all the, you see some of these buildings also done in steel. External. So these are the light gauge form steel structures, that G+1 structure that was built within this factory. Move on. It's time to welcome this new technology, probably refine them to suit our design as cost parameters, working conditions. But then we all will probably succeed in catching up with the world in construction and yet achieve our own Indian flavor. Then and then only we will be worthy to say that we belong to one of the strongest economies in the world. It's steel alone which will make it happen. Thank you.